Hey guys, today we're going to solve LeetCode number 389. Find the difference. So we're given two strings, and the string T is has the same characters as the string S, and then we add one more letter at a random position. So we need to find the letter that was added. So a quick way to do this is just keep track of how many of each character are in the S string, and then do the same for the T string and check which character has a different count. So that would be, for example, here it would be E. So that would be the output. But this would have an O of n space complexity, where n is the size of your alphabet, so the size of the characters that you can have in your string. So here we have that we only have lowercase letters, and I can assume that this is the English alphabet. However, there's one slightly better solution where no matter what the alphabet is, you're always going to have a fixed amount of space consumed. And so that solution is actually pretty similar to the last one that I've shown you on my channel, so the last problem that I did. So we need one operation that, given two of the same character and done on both of those two characters, will have the effect of not doing anything at all. So what we're going to do is we're going to start with 0. So we're going to have like a result which is 0, and then XOR the character codes of every character in the two strings. And so since every character is there twice, or like an even amount of times, but the last that was added in a random position, like this one is going to be here an odd amount of times, right? So if we XOR an even amount of times every character, the result is going to be 0. And then sooner or later, when we XOR the last letter that was added, which is there an odd amount of times, then what's going to remain is going to be the character code of that letter, right? So yeah, that's what we're going to do. And just to be clear, here we're going to go for a bit of concise code. So since we know that this is one longer than S, we can use that to our advantage to have a bit of a shorter code. So yeah, we're going to take the length of the shortest string, and then we're going to take the last character of the second string. So we're taking out this. So now the two strings have same length, because we've already counted the last character that was added. So now we have our base value. This is our initial value. And what we're going to do now is we're going to loop through all other characters. So we're skipping the n+1, so the one that we've took here, right? And now we're going to go through all of the other characters and XOR them together. So you see, we're doing XOR of every character. And since sooner or later, here we're going to XOR every character that is in both strings 2 times, that's going to be the same as not doing anything at all. And so all that's going to remain is going to be the only character that is there an odd amount of times. And so what we can do then is just return the string that is made from the character code of that missing character, or of that character that is there an odd amount of times. So yeah, that's it. I'm going to submit it to show you that it works. And the time complexity here is O of n, where n is the amount of letters in our strings, and the space complexity is O of 1. So that's why this is great. The space complexity is O of 1, so it's constant, even if you have an increasing space of letters, so you have an increasing alphabet size. Okay, so that's it from me. Thank you for watching, and bye.